There is lots of material available on the teaching page for Chemistry 3720 of both the YSU and the hyperconjugation.com addresses. For example, links to the syllabus, the lab material from Dr. Jackson's website, the recitation syllabus, and also the lecture slides will appear on both. The past exams and the problem sets likewise are on both, and some of these tutorials that we've developed will be on both sites. However, I will update both of the sites with the basic information, but you'll find that hyperconjugation.com has extra tools found on the right over here in the window that will allow you to practice and conquer the material found in 3720. What you will find of immediate interest on the Chemistry 3720 page is this link to the simulation of NMR spectra. In chapter 13, we start looking at some of the physical properties of organic molecules and some of the techniques that we have developed to be able to look at what a molecule actually looks like. You see here we have this Java-based tool that works on the iPhone and the Android phone. It also works on tablets and the PC and the Mac. And it allows you quite quickly to be able to draw organic molecules, very similar to the ChemDraw tool that we have in the lab. To be able to draw molecules, we can change the atoms that are in the system, and we can move things around quite easily. And then we can generate the spectra. So you'll see very quickly what these things look like. We have a scale at the bottom, depending upon whether it's a carbon spectrum or a proton spectrum. We can increase the size of the signals. These signals down here in the proton spectrum look really bunched up, so we can actually expand those quite easily. And likewise up here, and very quickly these signals, these shapes will mean something, and that information will tell you an awful lot about the structure of that particular molecule. Most of the information on the website is compatible with most of the browsers and platforms that are available now. However, some of these newer things, such as this convert 2D models to 3D, you require the use of WebGL, which is a newer development for the expression of three-dimensional molecules in a browser. Ironically, this works on my phone, but it doesn't work on my computers too well. You see here that we have now moved to Google Chrome, and this now allows for the depiction of a 3D molecule. This is simply methane. This will be more useful in 3719 in the future, but you can see again this interface to be able to draw a simple organic molecule, add components as you see necessary, and change some of the atoms to be able to make all kinds of different systems, and then generate the 3D model. You can see here simply the planarity around the benzene system and the double bond system, and this will be very useful in the future. Unfortunately, it won't work on a lot of the browsers that are available right now, but this is something that will catch up in the near future. Also on the hyperconjugation.com website, and using Google Chrome as the browser, we have this low 3D model representations, and this is something that will be very interesting for anybody interested in medicine or pharmaceutical chemistry. This is a database from which you can call the structures of all kinds of different pharmaceuticals. There is a list here of common pharmaceuticals. If you want to look at something called tetracycline, it very quickly loads up and you can move this in 3D space. The problem again is that this is not available just yet on a lot of different browsers. This is something that the web is catching up with. We can change the representation to the ball and stick that is common with the models that you can buy, and the Van der Waals forces, the Van der Waals spheres that allow you to see the actual size of the atoms relative to each other. And as you move towards biochemistry, you see that these wireframe pictures become useful because the molecules get so big and so dense that seeing every single atom is difficult. And down here we have a search possibility for a database called PubChem, which again allows you to view this molecule or any molecule that you're interested in this window. So this is something that will be useful in both 3719 and 3720, and as the internet and the browsers catch up, I think this will become quite valuable for learning organic chemistry. So there's an orientation of the website: research, teaching, advising, the homepage. Hopefully you will find this useful.